Hi, good day. Let us learn about Boyle's law. Let us consider first the relationship between the pressure and volume of a gas when both the number of molecules and their average kinetic energy are constant. That is, they do not change when the pressure and volume change. Consider the container of gas with a movable piston as shown in the figure. If the piston is lowered until it is half the original distance from the bottom, there is only half as much space as before. The same number of molecules occupy half the volume. The molecules hit the walls of the container twice as often with the same force per collision. So, the pressure is twice as high when the volume is half as much. We conclude that at constant temperature, pressure increases as volume decreases. More precisely, the pressure varies inversely with the volume. The product of pressure and volume is then a constant. The British chemist Robert Boyle arrived at this principle by experiment 300 years ago. The relationship is called Boyle's law. Boyle's law states that if the amount and the temperature of a gas remain constant, the pressure exerted by the gas varies inversely as the volume. When we put the relationship into mathematical form, we obtain P varies 1 over V. Then, P is equal to K over V, or PV is equal to K. In this equation, P is the pressure and V is the volume. The K is a constant that takes into account the number of molecules and the temperature. Thus, pressure varies inversely with a change in volume. If we know the volume of a gas occupies at one pressure, we can use Boyle's law to calculate the volume it will occupy at a different pressure. For example, it is difficult to experiment with gases under standard conditions. Experiments are often carried out at room temperature and pressure. Since the temperature and atmospheric pressure vary from day to day, experimental results cannot be compared easily. It is desirable, therefore, to adjust all results mathematically to standard conditions. If P1 is measured pressure and V1 is measured volume, P2 is standard atmospheric pressure, and V2 is volume at standard atmospheric pressure, then V1 is equal to K over P1 and V2 is equal to K over P2. In the first equation, K is equal to V1 times P1. Since K is a constant, we may substitute V1 times P1 for K in the second equation. V2 is equal to V1 times P1 all over P2. We have derived this relationship by using Boyle's law. Note that the original volume is simply multiplied by the ratio of the two pressures to find the new volume. In dealing with changes in pressure, there will always be possible two pressure ratios, one of which will be greater than 1 and the other less than 1. Let us try to solve this problem. The inflated balloon has slipped from the hand of Ren, has a volume of 0.5 liter at sea level, equivalent to 1.0 atmosphere, and it reaches a height of approximately 8 kilometers where the atmospheric pressure is approximately 0.33 atmosphere. Assuming that the temperature is constant, compute for the final volume of the balloon. In analyzing the problem, it is important that you categorize the initial and final conditions of the variables. The initial conditions are: initial volume is equal to 0.5 liter. The initial pressure is equal to 1.0 atmosphere. While the final conditions are V sub 2 is the unknown, P sub 2 is equal to 0.33 atmosphere. By applying Boyle's law, can you predict what will happen to the final volume? Yes, you are right. The final volume will increase. Let's compute for the numerical value of the final volume by substituting the given values to this equation. V sub 1 times P sub 1 is equal to V sub 2 times P sub 2. V sub 2 then is equal to V sub 1 times P sub 1 all over P sub 2. So, V sub 2 is equal to 0.5 liter times 1 atmosphere divided by 0.33 atmosphere. The answer is 1.5 liters. Did you notice the decrease in pressure and how it affects the final volume? The pressure decreased by 1/3. That is why the volume increased by 3 folds. Try to multiply V sub 1 by P sub 1 and V sub 2 by P sub 2. Does it have the same product? Isn't it amazing?
If this is your first time watching my videos, make sure you hit the subscriber button. Thank you for watching.